So, good afternoon, my dear students. My name is Dr. KCH Apparao, working as an associate professor in mechanical engineering department. So, in previous classes, we discussed the lectures on numericals on radiation topic. So, previously we covered the conduction and convection and radiation also. So, we completed the three modes. The first one is the conduction, second one is the convection, third one is the radiation. So, in this class, I would like to explain about introduction of boiling and condensation. What is the importance of the boiling and condensation? Okay, so we already covered the three modes: conduction and convection. So, in conduction, we didn't see any molecular movement or bulk movement of the particles, only vibration due to vibration, lattice vibration, or electrons movement, passing of the electrons. So, conduction will be taken. We already discussed. But in convection, it occurs in the fluids. You know this one. So, in convection, bulk movement of the particles should be needed. We know that. So, it means flowing of or some fluid on any particular surface. This is the surface temperature. This one is the fluid temperature TF. Then, so these particles, fluid particles moves on a surface. Automatically heat transfer takes place from the solid to fluid. You know this one. The formula is equal to Q is equal to HA into delta T, means TS minus TF. So this one already covered in the previous classes. We already covered the types of convection, two types: natural convection and forced convection also. But there is some relationship between the boiling and condensation, the convection. So in convection, so we didn't see any phase change. It means we'll see only heat transfer from the solid to liquid or solid to fluid, fluid to fluid. You know this one. But in case of boiling and condensation, so we'll see both things. One is the heat transfer from the solid to fluid. Next, phase change. Phase change from the in fluids. You know that fluids are two types. One is the liquid and vapor. So phase change means sometimes liquid is converted as vapor and vapor is condensed as a liquid. So liquid is evaporated as a vapor, means so that is called boiling. Or vapor is condensed to liquid, that is called condensation. Here it means we consider the phase change along with convection process. Convection process means heat transfer from the from solid to liquid. So the flow is, water is flowing on this one. So this is the temperature of the surface Ts. So we'll see if the temperature of the saturation temperature of the fluid, so then delta T is the temperature difference, that is the temperature difference, solid temperature to saturation temperature. If there is excess temperature, we will see the vaporization or evaporation. We will see some introduction about this boiling and condensation, and what are the different applications of the boiling and condensation. The first point we'll see. So convection process is associated with the phase change. It means that is called in boiling and condensation. We will see the convection process is associated with the phase change. It means here we will see the convection process plus phase change also. Convection process means heat transfer from solid to fluid, and phase change, so changing of the phase from liquid to vapor or vapor to liquid. So these things occurred in the boiling and condensation. That is called boiling and condensation. So here one thing we have to observe this one. It means this is the solid surface, the water is flowing like this one. Saturation temperature this one, solid temperature this is. Here just like water is moving on a surface, it means heat transfer takes place from the solid surface to liquid or fluid. So then due to high temperature difference, the water is evaporated or converted into vapor stage. Converted into vapor position. So here just like, but one thing we have to observe here, that one, the heat is transferred from the solid to liquid in case of the vaporization, in case of phase changing, but we cannot observe any changes of temperature. It means fluid temperature does not change, but we will see the phase change. So it means that the taken temperature, that taken or heat transfer from the solid to liquid temperature, the temperature that is called latent heat. That latent heat is used to change the phase from liquid to vapor or vapor to liquid. So that is called latent heat. So here latent heat effects associate with the phase change. So first one is the convection process associate with the phase change. Latent heat effects associated with the phase change. It means heat transfer takes place, but we cannot observe any type of heat transfer, but that heat should be converted as a latent heat. That latent heat is used to phase change. We'll see. So next one, so vaporization of liquid to vapor state resulted by heat transfer from the solid surface, that is called boiling, you know this one. Condensation of vapor to liquid, so vapor to liquid, so that is condensation. Is this one also results in the heat transfer to solid surface. It means in the boiling, heat transfer from the solid surface to fluid. In the condensation, heat transfers from the liquid to solid. We'll see these things. So how to observe this one. So along with some parameters, some important parameters, just to namely surface tension at liquid vapor interface and density difference between the two phases. These must be considered here also. So along with latent heat, two other parameters. What are the parameters? Surface tension and density difference. They should be considered for the study of this boiling and condensation also. So these are the base brief description about or the brief introduction about the boiling and condensation. So now we'll see some applications of the boiling and condensation. So we'll see some, these are the very important applications of boiling and condensation. The first one is the cooling of nuclear reactors. So it is very important to application of boiling and condensation in rocket motors also. So for the cooling system, Next, in steam power plants also, this means boilers and condensation. This process, boiling and condensation process, is very important in steam power plants. Next, refrigerating and air conditioning system also. So this one also very important application of boiling and condensation in AC and AC systems. So next, melting of metals in furnaces. In furnaces also these applications are very important. Next, refiners and sugar mills for the heat exchanger processing. Here also we'll see this type of application. And process heating and cooling. So heating and cooling of the processes. Here also we'll see these applications. So we can see boiling and condensation applications are very high in different areas. So nuclear reactors and rocket motors and steam power plants and AC systems and furnaces workings. So how to study about this topic, boiling and condensation, because it has huge application in different areas. So next, here we will see some unique features of the boiling and condensation process. We know that as a consequence of phase change in these processes, the heat transfer to or from the fluid can occur without influencing the fluid temperature. It means heat transfer takes place, but we can't observe the heat transfer differences or raising of the fluid temperatures, but the taken temperature will be used to phase change. So we have to identify that one. So next one is the heat transfer coefficient and rates. The heat transfer coefficient and rates due to latent heat associated with the phase change are generally much higher compared to the normal convection processes. We know that to normal convection processes without phase change. So here we can observe this one also. Next, high rate of heat transfer is achieved with a small temperature difference. Here, just like delta T, that is the solid temperature to saturation temperature. So for the less or very small temperature difference, we will see high rate of heat transfer. Rate of heat transfer is very high. So these things are very important. First of all, we'll see here two types of the process are there. One is the boiling, another one is the condensation. First of all, we'll see the boiling. What is boiling? What are the types of the boiling? What are the applications of the boiling also? We'll see boiling is the convective process. You know this one, convective process with phase change. So phase change means here phase change, what type of phase change? Liquid to vapor state. It means vaporization. It means convection process with vaporization. That is called boiling. So convection process, heat transfer takes place from solid surface of fluid and including or associated with the phase change. So that is called boiling. Boiling also defined as the evaporation at solid liquid surface. Evaporation at solid liquid surfaces. At solid liquid surface, or if you consider water here. So if you boil this one, the evaporation will occur like this one. So this is called boiling. Boiling of any fluid. Next, this is possible only when the temperature of the surface, so that is the Ts, exceeds the saturation temperature. Exceeds the saturation temperature, T saturation. If there is a temperature difference delta Te, so then boiling will occur. So next, heat transferred from solid surface to liquid. Here heat transfer takes place from the solid to liquid. Solid to liquid. It means Ts minus T saturation of fluid. So here you will see the boiling process. So boiling process is nothing but convective heat transfer process associated with the phase change. Phase change means vaporization. It means liquid to phase changing of liquid to vapor state. Okay. So here we'll see the formula for this one. You know the convection process, rate of heat transfer for the convection process. Q is equal to HA into Ts minus T saturation. Heat transfer coefficient, you know this one, area of the surface, and T is the surface temperature, Ts, and T saturation. So saturation temperature of the fluid. So that is called, you can write like this one, delta Te is equal to saturation, surface temperature minus saturation temperature. If there is a, this is called excess temperature. If there is a excess temperature, we will see the boiling process. Boiling process is nothing but, so due to heat transfer process, due to convection process, phase change will occur. Phase changing means liquid state is converted into vapor state. So that is the boiling. Now we'll see the different types of the boilings. So first one is the pool boiling. So what is pool boiling? We'll see. In this case, liquid above the hot surface is essentially stagnant, and its motion near the surface is due to free convection. So suppose this is the container, water is here like this one. If you heat this one, okay, here water is stagnant position, but heat transfer takes place from the free convection. You know that due to buoyancy effect, heat is transferred from bottom to top, because less dense particles moves into the downward direction. High density particles moves into downward direction. Less density particles moves into upward direction. So due to heat, the density of the particles will be reduced. This less density particles moves into upward direction. So in this way, so evaporation will see occur at the top surface of fluid. So this is called pool boiling. Pool boiling is nothing but, so in this case, liquid above the hot surface. Liquid above the hot surface is essentially stagnant, and its motion near the surface is due to free convection. Mixing induced by bubble growth and detachment. So this mixing induced by the bubble growth and detachment. The pool boiling occurs in steam boilers. Mainly you will see this type of boiling in steam boilers. Boiler, steam. Okay. So next one is the forced convection. And forced convection means here movement of the particles will occur by some external agent. You know this one. This is based on the natural convection. This is based upon the forced convection. Okay. This refers to a situation where the fluid motion is induced by external means. So here, motion of the or movement of the particles occurred by some external agent. The liquid is pumped or forced to flow. This type of boiling occurs in water tube boilers. Here, steam boilers. This application, pool boiling application, you can see in steam boilers, and forced convection boiling will see in water tube boilers. Okay, so these are the applications of pool boiling and forced convection boiling. Now we'll see one more boiling, that is the local boiling. Local boiling or subcooled boiling. So in this case, liquid temperature is below the saturation temperature. Liquid temperature is the below the saturation temperature, and the bubbles are formed in the vicinity of the heat surface. These bubbles, after traveling a short path, that then get condensed into liquid. So because of the less temperature, the bubbles are converted into liquid. So this is the process that is called local boiling. So initially the bubbles will form. So these bubbles will rise. Here, due to less temperature, these bubbles are condensed and converted into liquid form. So this is called local boiling. Now next one is the saturated boiling. This is very important. Here liquid temperature exceeds the saturation temperature. Liquid temperature exceeds the saturation temperature. Here liquid temperature is less than the saturation temperature. Here liquid temperature is exceeds the saturation temperature. Automatically vapor bubbles are formed at the solid surface and then propelled through the liquid by buoyancy effect. If you see this one, so the water bubbles will form. These less dense part bubbles or vapor bubbles are comes in upward direction and reaches the free surfaces, and the here we'll see the phase changing conversion of the liquid into vapor. So it occurs at the saturation boiling process. This is type of saturation boiling. So these are the four types of the boilings. Now we'll see the boiling curve. So phase change processing of phase changing in boiling process. So this is the heat transfer rate, heat flux curve. So here we'll see three stages. One is the interface evaporation or free convection process. Second one is the nucleate boiling formation, and film boiling, and just formation of one layer at the surface. So nucleate boiling and film boiling. So first free convection. Free convection means heat transfer takes place uh, from one position to another position. But it means heat is transferred from the solid surface to liquid. We'll see. So next we'll see formation of the bubbles. So that is the second phase. Third, we'll see the formation of the film, just like formation of film like this one. Okay. So this one is the third phase. So we'll see one by one. The first one is the interface or free convection. So here heat transfer by superheated liquid rising to the liquid vapor interface. So here where evaporation takes place, it means due to the buoyancy effect, the heat transfer takes place from bottom to top at the free surface of the water. So here we'll see the vaporization of water. It means the phase change we'll see here. The water is evaporated into just a vapor state. So here this one is the process. This is the boiling curve. The temperature is this temperature difference. It means delta TE solid surface temperature minus saturation temperature of the fluid. That is the nearly 5 degrees Celsius. This is the curve 5 degrees Celsius. If the temperature difference or excess temperature is less than or nearly 5 degrees temperature, you will see the free convection process. It means heat transfer takes place from the solid to liquid surface automatically at the top surface at the liquid vapor interface. You will see the evaporation process. So next one is the if the excess temperature is increased, just like here 5 to 50 nearly. Okay, so we'll see bubble formation. So initially bubble will form, but the bubbles will be condensed again before reaching the top surface of liquid vapor interface. Next stage, bubble rise to the surfaces. We'll see here bubble formation we'll see, but these bubbles will be condensed again. But here, this bubble formation we'll see, and these bubbles comes to top surface of this. So interface of liquid vapor process. Here you can see here also. You can observe this same diagram here, like this one. In the natural convection boiling, just to heat. So this is just like surface temperature. This is a saturation temperature of the water. You know this one. If the say less difference is there, it means 3 degree Celsius, 1 or 3 minus 100. So less than 5. So here just heat transfer takes place from the solid surface to liquid, and this heat is transferred from throughout the fluid because of natural convection by the effect of buoyancy. At the top surface, here interface of liquid vapor, here this water is evaporated. We will see evaporation of water. So this is the natural convection of boiling. So next one is the nucleate boiling process. Nucleate boiling process means up to temperature 10 or more than 10, 20. Here also just like 110 to 100, surface temperature is equal to 110 and the saturation temperature is equal to 100. So delta T is equal to nearly 10. Here bubbles are formed, and these less dense bubbles are moves to upward direction. When they moving, because of less temperature, these bubbles are recondensed again, converted into liquid. So these bubbles are not stable. These bubbles are condensed to liquid. Here in this process we will see this one. Bubbles collapsed in the liquid. Bubbles collapse in liquid. So due to less excess temperature. Next one, if you see the temperature, if the heat transfer rate is increasing, here just like 10 to 30 or 50, here bubbles are raised to the free surfaces. Bubbles are formed, and these bubbles reach to top surface of the fluid. So that is the process. Here up to this point, heat transfer rate or heat flux will increase rapidly. So here you will see the maximum heat flux rate, Qmax, critical radius of heat flux. Here also we'll see. This is the critical point. So based upon this critical temperature, just to have to choose that material also, because the material should withstand at temperature. Otherwise, the material's properties will be varied. Okay, so we have to construct this one. That is called. We'll see this one. So this one is a critical heat flux point. So up to point C, here means point A. Here we consider only 2 points. Critical heat flux point is the maximum heat transfer rate is going rapidly here from point B. So here just like up to point C, in the nuclear boiling, 2 phases we'll see. First of all, bubble condensed into superheated, bubbles formed but condensed due to less temperature. Here bubbles are raised to surface temperature. So due to bubbles rising, the heat means heat transfer rate or heat flux is increased rapidly. So at that point, heat flux is very high. That is called critical heat flux. So we'll see what is the importance of the critical heat flux also. So from next phase is the film boiling. From this point we'll see again the heat fluxes will reduce. Means heat transfer rate will be decreased due to vaporization of the surface. It means the bubbles are combined with each other and some film type layer is formed on this surface. Here, here three phases we'll see. One is the unstable film. Next one is the stable film. So first of all, we'll see unstable film here and here and here near the surfaces. We'll see. Otherwise, here we can observe this one. This is the unstable film. Unstable will film formed on the surfaces. Due to this evaporation pockets, heat transfer rate will be decreased from the surface to fluid. Okay, due to this rate of heat transfer, less rate of heat transfer, automatically heat flux rate will decrease. So the it will decrease up to point to D. So lead in first point, you know that Q minimum. This is the heat flux Q maximum. These 2 points are very important. Okay. So after this one, then the complete vaporization will occur on the surfaces. This complete layer is covered the surface vapor film is covered on the surfaces. So due to this one, this act as a just solid surface, automatically radiation process will occur. Due to this radiation, the heat transfer rate is or heat flux is increases rapidly. So here then you will see this one. So first of all, heat transfer rate will increase, then decrease, then increases rapidly. So this is the phase of boilings. So in the boilings, three phases are there. One is the free convection phase, another one is the nucleate boiling phase, third one is the film boiling phase. In the free convection, due to the free convection, heat transfer takes place. Automatically at the top of the fluids, we'll see the boiling process. It means evaporation process. So second phase, nucleate boiling. It has two phases, phase 2 and phase 3. In the phase 2, due to less temperature, excess temperature, bubbles will form, then condense to liquid. In third phase, bubbles will form and rise to the surfaces. Due to rising of these surfaces, automatically heat transfer rate will be increases. It means heat flux will be reached at a maximum point. That is called critical heat flux point. But after this one, we will see the film boiling process. It means these bubbles are combined with each other and some vapor layer is formed on the bottom surface. And these pockets are unstable pockets are formed on this one. Automatically rate of heat, these pockets resist the rate of heat transfer from the surface to liquid. Automatically heat transfer reduces. Heat transfer rate is reduces. So this is called unstable film. So after that, we will see the stable film which is formed on the surfaces. Due to this stable film, it has we will see the radiation processes. Radiation, it means it layer act as some solid surface, and radiation process we'll see. Due to this radiation, heat transfer rate is increases rapidly from solid surface to liquid. So continuously increases here. So we'll see some points regarding this one. First one is the interface evaporation. It means the free convection process, phase 1. We'll see three phases. One is the free convection, next to nucleate boiling, third one is the vapor boiling. Okay, so first interface evaporation process with no bubble formation. Here we didn't see any bubble formation, but heat transfer takes place from solid surface to liquid. At the top of the liquid surface, you will see evaporation process. So it exists in region 1. It is called free convection zone. You know this one. Here, excess temperature is very less. Delta TE is less than 5 degree Celsius. You know this one. So in this region, liquid near the surface is superheated lightly. The convection currents circulate the liquid and evaporation takes place at the top surface. Evaporation takes place evaporation takes place at the top surface of the liquid. The surface temperature must be somewhat above the saturation temperature. There must be some excess temperature, delta T. You know that delta T is equal to solid surface temperature minus saturation temperature. There must be some amount of excess temperature, at least up to 5 degrees Celsius. We will see this type of evaporation. So this is called free convection boiling. Second one is the nucleate boiling. Nucleate boiling, it means bubble formation we will see. So here also two phases are there. One is the unstable bubbles, and second one is the third. So stable bubbles form and reaches to the top surfaces. So here heat transfer rate rapidly increases. Here heat transfer rate, so little bit increase we can see. So with the increase in excess temperature, it means after the free convection process, if you see the excess temperature, it means excess temperature delta T is more than the 5 degrees Celsius to nearly 50 or 30 degrees Celsius. You will see with the increase in excess temperature, the formation of bubbles on the surface at certain localized spots, so as indicated in the region 2. In the region 2 here, you will see in this region 2. So bubble formation we'll see. Okay, the bubbles condense in the liquid without reaching the liquid surface due to this less delta Te in phase 2. It means in nucleate boiling there are phase 1 and phase 2. In the phase 1, the bubbles condense in the liquid. Bubbles forms, but due to less temperature, these bubbles are condensed into liquid without reaching the top surface of the liquid. So with further increase delta T, if you increase if the delta T is the more than the greater than the 10 degrees Celsius, the bubbles are formed rapidly and rise to the top surfaces. Top surfaces liquid, resulting in rapid evaporation. Evaporation rate will be increased. So as indicated in the region 3 here, you will see region 3. Here bubble formation increases rapidly and reaches to the top surface. Evaporation rate will be increased. Here bubbles are condensed again because of less excess temperature. We'll see. The nucleate boiling is thus characterized by formation of the bubbles at nucleation sites and resulting the liquid agitation. The bubble agitation induces considerable fluid mixing that promotes the sustainable increase in the heat flux. So here we will see the rapid increase of heat flux. So that is called, it reaches a particular point that is called critical heat flux. Nucleate boiling exists up to 50 degrees Celsius, 30 to 50 degrees Celsius. The maximum heat flux that is called critical heat flux that occurs point A according to this diagram. This is called point A. According to this one, this is the point C. Critical heat flux, we'll see this one. Okay. So next one is the film boiling. Film boiling also had a unstable film formation. Next, first unstable film formation. So next radiation processing. So the trend of increasing heat flux with increasing excess temperature observed in the region 3. This is the region 3 boiling, film boiling. Here bubbles are combined with each other and forms the vapor layer that is called film on the bottom surface of the surfaces. So these are film pockets. So these are unstable pockets of the film formed on the surface of this solid surface. So these pockets resist or opposes the heat transfer rate from the solid surface to liquid. Automatically heat transfer rate will be decreases. So this is due to fact that bubble formation is very rapid and the bubbles blanket the heating surface and prevents the incoming fresh liquid from the taking their places. Okay, so eventually the bubble coalesce and form a vapor. This it means these bubbles are combined with each other and forms the vapor film. So this is so since the thermal conductivity of vapor film is much less than that of liquid of heat, because these vapor pockets resist the heat transfer rate from the solid to liquid. So heat transfer heat flux curve is decreases in this condition. Next to so film boiling, if the excess, it means within the temperature range 50 to 150 range condition, uh, it means so the vapor pockets or vapor layer is formed on the surfaces that form that acts as some solid layer. Automatically, radiation comes into picture. So automatically, heat transfer rate will be increases from the solid to this layer, next this layer to liquid. So the further increase of delta T, vapor film is stabilized. Film is stabilized. Heating surface is completely covered by vapor blankets, and the heat flux is the lowest as shown in figure. That one is the surface temperature is required to maintain a stable film and high. Under this condition, a sizable amount of heat is lost by the surface due to radiation. Okay, so due to radiation, the heat will be increased. So you'll see in the fourth reason, this phenomena of stable film region can be observed when the drop of water falls on the red hot stove. So we'll see, this is the example. So in this way, in this area, automatically due to radiation process, automatic heat transfer rate will be increases. It means heat flux is increased rapidly, continuously. So that we'll see this one. So this is the just like so three phases of the boiling curve. So we'll see some few points regarding the critical heat flux. We'll see critical heat flux in C in the end of nuclear boiling at the point C. This is the critical heat flux. Okay. So few points regarding the critical heat flux. Critical heat flux or burnout point is the point of maximum heat flux on the boiling curve. So at which transition from nucleate to film boiling. We will see so bubble formation to film boiling. This is intersection position. So from this point, bubble formation is converted into film boiling, or nucleate boiling will end and automatically film boiling will start. This point is also called as the boiling crisis, because the boiling process beyond that point is unstable unless of curve point B is reached. Okay. So the temperature at the point B, is extremely high and normally above the melting point of solid. So if the heating of the metallic surface is not limited to point A means critical heat flux point. So the metallic surface, you have to identify the metal, choose the metal to boil the water. If the metal temperature, metallic surface temperature is less than the critical heat flux point, automatically some damages will occur. So it is possible that the metal may get damaged. It may even melt. So because if the metal temperature is or the melting temperature of the metal is less than the critical heat flux, automatically we will see some damages of metal also in the boiling processes. So thus we may be interested to operate the equipment close to this value. So for the identification of equipments or equipment safety, then we have to consider the critical heat flux point also. We have to find the critical heat flux point also. So these are the important points of boiling curve. So these are the different references. Allman and Sachdev and Rajput. Rajput is very important regarding this topic. You can refer this one. So this is a just like brief description or introduction about the boiling and condensation. So next class we will see different numericals based upon the boiling. So thank you, listen this class. We'll continue in next class also. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.